Now proceed with our next session, which is about next-gen connectivity. Unlocking the potential of smart satellite, we'll experience the future of space technology through the lens of smart and flexible systems. We'll explore how these adaptable solutions, coupled with innovative spacecraft design, promise a secure and resilient future. This integration enables responses to evolving challenges in space exploration and beyond. I would like to welcome our chairperson, Mr. Rainer Horn, Managing Director, Novaspace. Also, our panelist for the session, Mr. Gurvinder Chohan, MD, Reliasat, Mr. Rakesh Bhan, AVP Satellite Operation, TASL, Mr. Siddhartha Sagar, Director, Avantel, Mr. Rupesh G, XDLINX Labs, Mr. Michael Dowries, Technical Sales Engineer, NewSpace System. Now I request Mr. Rainer Horn to please conduct the session further.
Hello everybody, welcome. I hope you had a nice lunch. And I have the pleasure now to lead you through this discussion, which we plan to do very interactively. So please be ready to ask questions 1 or 2 times in between. Otherwise, we'll not run out of questions here on stage. I have a distinguished panel here of professionals working in various aspects of this topic. And I would like to give every one of them now the chance to briefly introduce themselves.
Hello, my name is Siddhartha. I'm Director of Business Development and Strategy in Avantel. And hope everybody's doing and having a great time today. That's me.
Good afternoon, everybody. And I hope you guys are not sleeping or fall asleep during or after our presentation. And our job is try to keep you awake. And I will make sure I will ask you a few questions in between. So be ready. So just to let you know, my name is Gurvinder. I'm the MD or CEO for Reliasat. We are based in Montreal and UK. I've been in the space industry for about 2.5 decades. So we'll talk when we go through, but I have seen the evaluation from tons of satellites to kilograms of satellites. I have gone through that whole cycle. And I really appreciate if you ask more and more questions, challenging questions so I can answer. So I look to have interactive session with you guys.
Hello. Good afternoon to everybody. My name is Rakesh. I represent here Tata Advanced Systems Limited. Tatas have recently gone into space with the TSAT-1A satellite, which was launched on April 7th this year. We'll talk more about this, but about me, I come from 2+ decades of experience from Indian Space Research Organization. And I, as Mr. Gurvinder said, from the lower segment to higher segment of satellites. I come from the higher segment to the lower segment, from maybe around 3,000 kg satellites to now 150, 120 or less than 50 kg satellites. Because the world has become smarter now with smaller satellites, with the cost and constellation and operational things. So we'll talk more about this. I hope I will be able to answer all your questions and introduce Tatas, what Tatas are doing, what is our vision, and what we look at market from now to the next 5 years to 10 years. And what is the sweet spot for the smaller satellite segments in constellation? Talk more about that. Thank you.
Hi, I'm Rupesh Gandapalli. I'm co-founder, CEO, XDLINX Labs. So we are into offering the satellite platforms with the payloads and the other space stuff. We are located in Hyderabad. We are a 2 years old company. So we have bigger plans to launch few satellites this year and next year and following years.
Thanks for the opportunity to be here today. I'm Michael Dowries. I'm the technical sales engineer at a company called NewSpace Systems. I won't go into much detail now because I'm sure we'll dive into it a bit later on, but we're a company based in South Africa and we're supplying GNC hardware for attitude determination and control of the satellite.
Okay, let's get into the first round of discussions to better understand what is behind this. So my 2 neighbors, Gurvinder and Rakesh, you've been working in various more traditional legacy satellite systems companies for many years, yeah? And now what were the challenges we had so far hindering in the traditional satellites the opportunities there? What are the smart satellites all about? What is smarter nowadays? Where are these innovations that we're talking about? Maybe Rakesh, you first.
Yeah, thank you. This question is, it is actually a very broad question. So let me answer you from the industries who are established previously, maybe 5 years back or 10 years back, who were established in space, were the companies who were already, who used to work with or have been, their working model is with the traditionally government-controlled organizations like NASA, like ISRO. So the model is more of supply chain to the bigger agencies like Lockheed Martin or big agencies like Airbus. So the economics is quite, it's in billions of dollars when we talk about the scale of their space business. But they have been traditionally towards the Western side, they have been a complete solution makers. But towards the Eastern side of the world, most of the companies have grown their models in terms of supply chain and in terms of components, not the complete system. So working this side of the world with a complete solution becomes a challenge as far as ecosystem is concerned. So we have 200 odd companies from last 3 years or 4 years in India who have just started their business in India. But that doesn't bring us to a consortium of companies. If I want to do something today, I want to make a satellite, I have to approach tens of companies, and I'm not sure that how do we put it together, because I need to be a system integrator in a way, because I want to serve, for a mission. So coming to this smart things are like, if I have to make a satellite, like I will give an example of Tata's recent satellite, TSAT-1A, which is in public domain, 0.7 meter native resolution, 0.5 meter super resolved, with very sleek, less than 50 kg satellite. If you will talk to the traditional companies or government-controlled companies like ISRO or NASA for the same spec of satellite, it will be not less than 300 to 400 kgs. Taking it to the space, every kg matters. So the smart things are to do such a spec satellite in less than 50 kgs. And you can just have ride share. We went to the ride share. It costs pennies to in the ride share. So this is what is smart about it. We are talking about edge computing, which will give you a thumbnail, whether you want to actually download that image or not, to save on the resources, what it takes to download each bit of the data from space. So if my image is not right, there's a cloud, I take a decision not to download it. I save at least the number of bits I download. So everything is smarter in terms of operation, in terms of the satellite technology. So when we talk about this smart technology, we need an ecosystem. This is where we are struggling now. This is our problem. We need the technology the consortium technologies who work together, who have bridged these gaps, that we are providing you the sensors, we are providing you the spacecraft, we're providing the operations, we're providing the data analytics. And if I want to make it, now building it from scratch, the ecosystem, building from scratch is time consuming, and again, there is an economics behind it, so we can't afford to have 3 years of R&D in terms of operation. I think I fairly gave you this thing. We'll come back on this question again. I will request Mr. Gurvinder if he's further adding on it.
Gurvinder, you have probably a complementary perspective, and you work with ecosystems around the world already, yeah?
Yeah, I'll try my best. So let's go back first, analysis, do the system analysis. Why do we need from bigger satellite to smaller satellites? Why do we need it? So having been worked with one of the largest manufacturers in the globe, where we have at one point we had about 80% of a commercial satellite market. So when I used to go to the operator, their biggest question was that my cost driver should be X amount per megabit per second. When I'm going to buy such a big satellite, $250, $500 million, that doesn't match up. My capex is too high. To recover my cost, I have to this many years to do, my break even will not come, and I don't have investor. So that drives the industry or manufacturer like ourselves to think out of the box, that how can we bring the cost down? What exactly can be done? So there are different ways to do it. So one of the things I was, okay, let's do it smaller, make it smarter, make it like when we say smarter, it's as simple as software driven. There's nothing magic. You can put whatever you say, but it's a software driven. You can call SDRs, onboard computers, all the jingles and bells, you can name it. But at the end of the day, it's just a software driven. you are reducing your dependency on hardware. So that's what it comes out to be. So no matter what name you can give. So that the industry or the end customer, like yourself, like I give you example yourself, that you were using your cell phones. You used to pay $100, $200 per megabit per second or gigabit to the operators. And now you have unlimited use of your data plan. Why? Because of that, the cost driven came down. The operator has less cost because we provide cheaper satellite, we provide smaller satellite, but higher throughput. So those higher throughput drives the cost down, and that benefit goes to the end user. So in a way, the whole ecosystem is made to benefit the end user, that's you. So there are many factors, like you are the main cost driver and our customer, which is operator. He says, hey, I need to reduce my cost down. That forces us to do R&D, develop some product and solutions, which drives down the cost. And that's where we are driving, making it smaller and smaller satellites and making it higher throughputs. And today I'm not going to do my publicity of my company. And I'm just going to talk as a professional as a teacher or a professor, whatever you can say. So if you want to see what we are doing, you can come to our booth. Then we can talk differently. But as here today, I will just talk from an industry perspective, where we are standing. So there are a lot of companies, for example, in the USA, they are building blocks like a Lego. They launch one Lego block, go in the space. You can name it whatever, manufacturing in space, space fab, whatever. So then you adopt another adapter, and you grew the capacity. So this is, again, a definition of smart. Like you are building something in space, starting from a smart block, and you keep on growing and growing. So there are many examples we can keep on going, but I don't want to hold my other friends, colleagues. So I'll pass it on to you to take on.
So Siddhartha, I mean, the end users were already mentioned, and I think looking at it more, what are the trends in the application markets that you see in the markets? Communications, I guess, first and foremost, you're serving maybe to some extent Earth observation. What is it that you see these smart satellites potentially doing or needing to do?
So to get to that, I'll actually start with the journey, because the journey is very, very important. And as one of his students, I'll talk about the next generation as well. So the journey of Avantel, we have been in the SATCOM space over the last 2 decades now, and providing innovative solutions to meet the needs and requirements of our customers. So we started out with 300 bits per second. Everybody would be laughing about, I mean, what do you do with 300 bits? I mean, a lot can be done, but we started out with 300 bits, one way. Then we did a 2-way communication, just over messages. Then with the same satellite, with the same specs, we actually enhanced our capabilities to provide voice at 2.4 kilobytes per second. And then we are actually advancing it to providing compressed streaming services as well. Now, in terms of applications, even though these data rates are very far away from where the next-gen satellites are actually capable of, we are still having a great impact. And why is that? So the entire Navy is actually using our communication, which is very, very critical to them in high seas, where there's no 4G or 5G or 3G, right? And if you look at the railways project, where in India, I mean, not everywhere do you actually find 3G, 4G. So with the combination of both 4G, 5G, and SATCOM, we can provide real-time services where automation can be established, and there's no station master who needs to do a check-in, check-out. And then I think everybody remembers the 2611 attack through phishing boats. Now we have received a project through PM3, where 1 lakh phishing boats are equipped with 2-way data communication terminals to be installed in every single phishing boat. So these are some of the key projects that we are actually part of and we are actually doing. So what's next? I mean, that's the next generation satellites, where higher throughputs, because if you look at some of the procurement that the Indian Defense is actually doing, all these fighter jets, aircrafts, they require, I would say the payload size itself, the starting size is 8 Mbps per second. And do our satellites, are they capable of providing that high speeds? The answer is no. So we need to ensure that we adapt to this next generation satellites to again continuously meet the needs and requirements of our customers. So that's at a very high level what Avantel is doing, and then
But also for the governmental requirements. So Rupesh, I understand you're a bit working in this area. The security and resilience are crucial aspects of these space systems. How do you see this evolving in this more adaptable environment?
Yeah, thank you. I think the smartness, right? The smartness is all about multifold, where without getting into design aspect, I think from the use case point of view, a system which can be adapted for the various missions and can be scaled, and also which can be smart, where the data can be provided as required then after the fact, basically, and also more importantly the system could be more supply chain resilient, that could actually adapt to the changes to the technology, where the platform can adapt various technology changes to kind of fit into the more and more next gen use cases, communications, Earth observation, security. So from the security point of view, which can actually protect itself, basically, from the earlier that traditional satellite is all about just doing its function by just capturing the images or enabling the communication. But now the most crucial aspect is to protect its own assets, basically. By so the security aspect is the most essential of the smartness in the new generation satellites. That's exactly what we're offering at XDLINX Labs. All our satellite platforms, what we're offering, has that the layers of security through the supply chain resilience and the adoption for the various payloads.
Well, thank you for that. So I understand we need also more specialized components on the satellites that make these activities happen. Now, Michael, in NewSpace systems, you specialize in certain components. Could you outline what specifically it is and what's the smartness about these components?
Yeah, sure. Thanks, Raina. So, as you mentioned, we're doing GNC hardware, and something that you might have noticed throughout the discussion is that there was quite a point raised on cost. So, cost factor is quite important. Yesterday we heard that the launch cost has actually decreased by about 90%. So that's quite a large number. It means that launch cost has come down. But now we look at things like the actual satellite, the components, the products, the things that you actually need to carry the mission out, your payload. So we really in a fortunate position where NewSpace Systems is based in South Africa. It's a low-cost environment. We're able to actually stay quite competitive with the market. And so that's quite a big driver in terms of what our customers are looking for. They're looking for competitive pricing, and they're looking for faster lead times. They're looking for products that's also up to the standard that they need for their missions. And so that's something that we maintain within the company. We've ensured that all of our technicians are certified, and so we ensure that we can work with various customers from the private sector up until your space agency. So we have a vast range of customers. It spans over more than 100 customers that we have worked with. So we're able to keep that competitive pricing, and the way we do that is by ensuring that we can meet the constellation needs. So we're delivering to customers that's doing more than hundreds of satellites. We're able to provide between 200 and 300 products per month, and we're able to do that quite stable within our manufacturing facility. Further to that, we've also ensured that we can have a semi-autonomous process. So when it comes to testing, there's autonomous processes with testing. We have certain processes where we actually have these production lines. So it's similar to what you see in the automotive industry, but still ensuring that we can have our technicians actually do the work themselves as well. So there's a bit of adaptability within that. And so that really allows us to keep that competitive edge, ensure that we have the quality that customers are looking for, and then, which we'll touch on a bit later, but just ensuring that we can keep the numbers that customers are looking for. So that's really important when it comes to these software-defined smart satellites that we're really seeing, and these constellation programs that are really popping up.
So you're really seeing that there is a new type of component requirement coming there from the market. Is anyone wanting to share some views on that, of what the supply and the demand actually is? Is it ready?
Let me take a crack on this. So I will answer your first question. I think you asked about the supply demand, which is where it's going toward. So again, I come back to the user cases, like what exactly the industry and user wants. That's what industry works. So as we all know, everybody says time is money. So previously, like let's say 5-6 years ago, we used to have the images downlink and terabits of different type of formats and data, PMZ and all those formats. And still being used. It's not, I'm not saying that. And I'm not against the downstream processing. But now the customer is asking a more smart, a more time efficient solutions. That means they want the image processing done on board. So when they get the downstream, they get the image. They don't want to deal with the trillions of megabit of data and wait. So with that, we have done some experiment. We have done it already. So we have onboard processing. So with that, what happens? You can on your mobile, you can select your area of interest. Hey, I want this image. I want this area of interest. You place an order. Next time satellite passes, you get your image right away. So you don't have to go through the downstream processing. You don't have to wait for the other companies to process the data and give you the image. So that's the one thing. The same thing goes for the comms. For the communication system, as you know, we have gone through the whole process. And now we are talking about E-band, W-bands, and all those high-frequency bands. So that means give you more and more power and more throughputs, more resilient. So with that, we need, of course, new type of components. So that's why I'm trying to make a circle, like where the demand comes, then how does the new component development comes, then how does it falls into the whole ecosystem. So this is how we develop the whole ecosystem, starting from the top layer, what exactly is required, how do you fulfill, and what's required to fulfill this. And that's how we see the demand for these new smart, like edge computing for type of stuff. And then now we are seeing more and more a software type, a whole satellite, where we have a less hardware, but a more software. So we have a one box, which is interfaced with everything. Before I remember, like 10-15 years ago, we used to have a payload interface unit, electric interface units, PDUs, and then whole decon, sub-converter, down converters. And then you have like hundreds of kilos of those mass just for the analog equipment you used to use. And now you have 100 gram of SDR, and that's doing the whole functionality. So that's where we are talking about the industry and the demand for the new component and next generation of the devices, components, and solutions.
I suspect you're talking mostly about private sector demand right now, mostly from the communications point of view. Yeah. Yes.
When I say I just combine both defense and because commercial, like what happens most of the time when you have a commercial demand, the defense sort of follows. Okay. They say, okay, commercial is doing this, we need to be a step ahead of them. So they choose to make it more complex, more complicated. So they show, yes, we are superior and we need our demands are more secure. So what happens due to that? You have more strict requirement. You need a more advanced equipment to fulfill those requirements. So these are a complement to each other. They go hand in hand.
It's really interesting discussion around dual use or serving both markets. Dual use is one aspect of it, but serving different markets as one operator. Maybe let me turn on the other side here to Rakesh. You're working on satellites and you serve both communities, and with Satellogic you've built a new partnership now where you also serve more commercial markets as well. How do you build this? How do you make it happen that you can serve both markets and also the requirements that both of these markets have?
Again, actually a very smart question. In terms of sharing the resources, in terms of our economics, how it works for the space, if there is a strategic community, which is a high value customer for us, in terms of the requirements of high resolution, in terms of requirements of the timing when they need it, and the cost behind it to put it to use for that strategic community is very high. So, but at the same time, the customer has to pay for how it meets the capex and the operational cost of getting that image, getting that solution, getting that communication time and bandwidth to the customer. Now that means now we have to find a number of other customers who are in public domain to use, I will say, reuse the resources or multi-use the resources. That's where the customers and the whole business has become smarter. Now the thing is coming down to strategic and non-strategic communities. The costing factor of and the serving factor and the economics of getting back that money is actually something different. Both the curves, they don't meet. Our job is to actually see how these curves actually together will cross our economic model curve, the resources we're putting in next 3 years of satellite lab or 5 years, and how do we cross it as soon as we cross it. And at the same time, when you see in the market, how the prices are coming down, even for the strategic community, how the prices of the communication, prices of the EO satellite data, the radars, everything has come down. I think from last couple of years, the prices may have gone down by half for the EO data. This is just a number. I mean, there are so many operators. To make it competitive is again the smartness in terms of, but when we talk about the resolution and a point of view, the strategic communities, actually there is a line. So when we talk about a non-strategic community, we need resolution of maybe 1 meter, 2 meter, which is application based. We don't require a 0.5 or 0.7 meter or 1 meter resolution for an agricultural application because they need it larger SWA, they need different, but we definitely need higher sensitivity of the data. So then we talk about strategic community, who is the high value customer, who will help us to get back the data, I mean the cost point of view. We talk about very high resolution, sensitive data. But when we take it together, put it in the same mission, becomes actually a challenge for us. Because now you have two different requirements which are actually contradicting each other. In terms of the satellite resources, I'm not talking about where the satellite should go. The satellite is same, but the requirements are contradicting each other. And if we put only one, we don't get that cost so easily back. The economics doesn't work for that. And if we want to put it together, then we have to put smart solutions on board. Now, as I told you previously, getting a thumbnail, getting that before we have to save on every corner of this mission. And that's how we are struggling with this, that how do our supply chains work. Now, another way is that we make a vertically integrated structure, which keeps us all the costs down in our own hands. We have supply chain in our hands, we have manufacturing in our hands, and try to reduce the third-party dependency. As Mr. Gurvinder said, the cost of putting this mission together is actually with the time, because there's a burn. There's a base burn which we cannot reduce beyond that horizontal line if we are making the mission delayed. So even though our hardware is same, but over time it adds up the cost. So many things in it. So we have to put smart solutions together, and the ecosystem. As I previously touched, ecosystem is more important. Yeah, please go ahead. Yeah.
Staying on the Earth observation side, Rupesh, I mean, you have different commercial partners. You are working with Axel Space and others in there. How are you dealing with this situation?
So on the, can you come again? That question. Sorry.
I'm just saying we're just looking at vertical integration.
Yeah.
We're looking at how you solve this in a smart business model more than the technology behind. From your perspective as a satellite builder, is it any different?
Yeah, so I think the whole aspect of this, getting this satellite smarter, so just think about how Apple achieved this the volume manufacturing, right? So Apple made this point to the system where the hardware has become more of a commodity, and the interface building is all about the software driven interface, right? And then they have standardized the processes where they can just drop in the equivalents of the subsystems, so that no matter what happens to which commodity or which subsystems gets impacted, or so if you look at that recent past, what happened 3 years ago with this whole rocket companies where there were delays in making those rockets successful launches. They actually raised a lot of funds just to manage this whole revenue. They just went after acquiring the component companies. So when I was at Planet, when we built 100+ satellites, I was heading the supply chain and manufacturing operations. We thought for a minute that we have that complete baked supply chain stack, which we can actually adopt for continue building hundreds of satellites to replenish the existing a fleet of satellites. But guess what happened? All of a sudden, Rocket Labs went after acquiring most of the component companies, and Raytheon acquired BCT and all that. But all of a sudden, what happened was all that baked costing model and the lead times what we had are no more valid, because they're all part of the bigger companies. Their appetite is much bigger compared to kind of how they used to operate with us. But now I need to go after hunt for the equivalents or somewhat closer to what we already have in our supply chain to kind of replace what we already using it. So there there is a need was created where we created a kind of standard model where by anticipating is going to happen again, basically. We just made this model standardized where we more define the software level interfaces than the hardware level, and kept that the complete satellite as a platform open, so that that could actually be adapting new components coming in, but also we want to try with the new things as it evolves. That also kind of enabled us to kind of increase the throughput of manufacturing to support mass volume, basically.
So less dependency on one supplier, making it open that you can work with alternatives.
That's right.
Okay.
To handle the multiple factors.
Okay. I will shortly open for a first round of questions because we touched on a very big number of aspects of smart satellites, even on smart businesses. So one last question for this round to Michael here. So the smarter payloads that you use in your subsystems, how do they respond to these changing requirements?
Yeah, so as mentioned, we have a manufacturing facility in South Africa, and what we've managed to do is that we've managed to keep the manufacturing, the testing, the design, all of that development, we do that in-house. We have a bunch of engineers, we have a bunch of technicians, certified technicians, and we're working according to obvious standards, but what that means is that we can be adaptable with what the market is asking for. We know that communication satellites are satellites. We're looking at in-orbit communication. All of these things have been popping up, and this is all due to these smart satellites that we see. So how do we adapt to actually meet the requirements? Part of that is just having things like reaction wheels that we manufacture. We're doing in-house balancing. We're ensuring that we can keep the spacecraft quite stable so that when you're having these interlinks with the satellites, you can actually have perfect communication with that, so that we can actually support these missions where they're having in-orbit communication for near real-time communication with on-ground. So that's quite important within the industry so that we can stay adaptable with what people are actually looking for. Further to that, in-orbit communication I've mentioned, and then also certain maneuvers and all of these things that people are looking at. Something that we've had to do was actually increase the accuracy of our GPS unit. So we've went from let's say 10 meters to accuracy within the centimeter range. So that's quite important that we can have a product that can actually work with what the customers, what the end users are actually looking for. So we've adapted in that sense, brought in new test equipment, had continuous development within the company so that we can support what the customers are actually looking for. Further to that, we've noticed that customers are looking for longer lifetime, they're looking for higher orbits. We still focus on LEO, but we're seeing higher orbits also popping up. So with that, we've also been increasing our radiation tolerance. So that's also been another continuous development that we've moved on with.
Yeah. So we have now a full perspective of the supply chain in these small satellites, from the components to various integrators and experienced integrators. So are there any questions here from the audience? Let's start in the first row. Sir? How many microphones do we have? Just these two? Okay. Can you just pass this one on? Please introduce yourself and who you address the question to.
Sure. So this is Damodaran. So my question to the panel is, when you talk about smart satellites, right? In my point of view, it's subjective. When we talk about vertical integration, that's what the people they talk about, right? And second thing is people, they have a right architecture and then make use of that, right? So which is smarter? If, in my view, if you want to become vertical integrator, it's very, very difficult to make everything, right? It's going back, you reinventing the wheel. Is it a smarter way? Or if you have only an architecture and you rely on somebody else, where is the security? I think we started taking about space as a commodity, right? But it's not. The space is still the space. Can you just elaborate on where your smart satellite fits into?
Who wants to take the question? Gurvinder?
Yeah. So let me answer in two different ways. One practical way, one is a realistic way. Practically, we have been doing vertically integrated. So we are fully vertically integrated. And we have been able to reduce our delivery time from a typical geo satellite, typical 20-24 months to 14 to 16 months. That's a smart way. Because we are fully vertically integrated, we have everything in-house, we can control the quality, delivery, schedule, price. When you're dependent on a supply chain, I give you an example last couple of years back, we couldn't find any microcontrollers in the industry. If you don't have a control on the supply chain, how you can call it a smart industry? Simple. Now the number one. The second part of the question was, what was that? I forgot. So that's what I'm saying. So that's cheaper, faster. That's why you have to have fully vertically integrated. You have everything in house. You control everything. So you had a second part of the question also, which just slipped out of my mind. If you remember what you asked. No, there was some other point also you had separate. So anyhow, so first part of the question is there, that yes, we have a smarter way, vertically integrated, you have in-house, you control better quality, price, schedule, everything.
I understand. This is also smart, this is also smart. Where we, smart satellite, where we need to be. It cannot be too extreme, right? It should be somewhere.
So now,
That's the confusion.
so second part, I now remember what I was going to say. I don't know if you have heard of the Industry 4. We have been talking about Industry 4 now, where it is that is a fully automatic robotic production line. The Munich University, they have been working it for over 5-6 years. We have been part of that. So over there, like in my last year in DevSat also, I had a presentation here where I had presented a video of Industry 4 revolution. What they're doing is that it's a chain. So you have everything in your vertically integrated product. Everything is in line. They pick and choose place. So their whole satellite is being like this. And they are targeting about 75 to 100 satellites of 100 to 150 kilogram class. So anywhere from 5 kilogram up to 150 kilogram. So it is not where you end or where you start. The answer is what fits to you. What exactly meets your demand. And how you can meet your demand and what meets your criteria of a successful satellite. That's what you need to look. We are not here to define this is good or this is bad. There's nothing good or bad. It's a definition and your perspective. Like how do you want to use this technology? Either you want to vertically, for some people it works fine. For some it won't.
Let's have some questions first from this side here. So some responses to the same question, but please keep it brief that we also can take some other questions.
I think like to your question, right? I think like you're asking about two things. Whether the smartness is like in terms of the vertical integration or like make the architecture so like it can enable the collaboration with the other the partners, right? So I think the way we think and how we operate is twofold. Both are valid, but like we vertically integrate to the point we play to our strengths, where and make that architecture so robust so that we can actually collaborate with the other technology players. To your question about how do we actually manage the security aspect or any adoption aspect, we treat the technology players which we don't sign up developing in-house as a partners than the suppliers. That way it's more of combined efforts in making the interface more robust so that there is no flaws while we are integrating and operating it.
Thank you. Anything you want to add to this one, or we go for the next round of questions? Okay, there was another question here. Has it been answered? Has been answered. Okay, any immediate questions from the audience before we go back here? No? First row over there.
This is Prashant. My question is from the, I'm drawing parallels with the computer industry. Like one of the reasons it flourished was standardization of protocols, the components, the interfaces. What is the current state of standardization in the satellite industry?
So my simple answer, we have NewSpace. So before we used to follow the ESA standard, NASA standards, and all those protocols. So now we came up with what we call NewSpace industry, and that's what follow now the new architecture and the new smart satellites. So with this, now we have a lot of new protocols we call CSP, CubeSat protocols. So that's another new definition of coming up, CSP protocol. And then you have industries, like ESA came up with a new space policy and new space industry codes and standardization. So for every generation when we have evaluation, there is a proper standardization and industry norm which we have to follow. But end of the day, back end, it follows from the origination. Like for example, a NASA standard, ESA standards, then these are a subset of that. But they are more to deal with today's environment, like how we can make it more efficient, how it can make it better. For example, now when we talk about NewSpace versus the old phase space, I remember we used to have the 5-6 ton satellites. They used to have 6 months of testing campaign, like a TVAX, environment channels and shakers and everything. And now, for the small satellites, they are not insisting on those. They're saying, okay, you need just do one vacuum cycle, and then you do one thermal cycle, and then you watch a vibration for 3-4 days, and that's it. You're done. So the norm cycle changes, and because now the electronics is coming more robust, the different type of technologies there. So they are no longer same. Before, as I mentioned earlier, we used to have tons of analog or mechanical equipment. There's not anymore. Now we have more smart PCBs, electronics, softwares, and there's no breakdown. So that's why they're not insisting on doing same testing. So that's why industry standard is there.
When you talk about 6 ton versus smaller, I think the entire things changes, right? Because why we are doing that for 6 ton is a different.
Than your CubeSat. I think it's totally different. So his question is basically, do we have any standardization per se? Perhaps I think Rakesh can pitch in. He's from ISRO, so hopefully.
Yeah, thank you. See, first let me start with your earlier question. One statement, what is smarter today will not be smarter tomorrow. So every day the smarter definition is a referential term. When we talk about 4-ton satellite to 150 kg satellite, if you compare what was 10 years back doing 4-ton satellite and what is now doing 150 kg satellite, is much better and much smarter. The 150 kg is much better and much smarter. How it came into picture, how it went into, what goes into it is again, a lot of changes have happened in every, from technology point of view, from user point of view. Now coming down to standardization, there are gateways of standardization, like what components I use, whether it's plug and play, that goes in technology side. But what a customer is concerned about is the standardization of the data he gets. Now we are talking about ARD, analysis ready data. It's like I give you a data from the satellite, which has typical format, which has GOT for any format. And another person, tomorrow I come back with another satellite, which is radar imaging satellite. Whether you can plug the same data into this analysis software, because you don't want to change. So you need standardization that way. So ARD is yet to come. Analysis ready data standardization is happening, it's coming. But then we are forced from the authorities and maybe the consortium industries that we should be meeting that standardization. So it becomes easy for us to just give the customer so that the gateways are well defined. So it is required, it's coming fast, and we have to adapt to that standard. So that's what the standardization is. But other side of the story is something different. So the standardization is everywhere. So if I want to get, I have to manage supply chain, as Rupesh also told, we have supply chains with respect to the cost. I want to replace this module of the satellite with another one. I cannot just plug if it is a different standard interfaces. So there are few standards which are already defined. And which are, of course, people want to do, there are still companies in commercial domain, non-space companies also who want to do their own standards. So they don't want to comply with, we can't stop that, but it doesn't become cost effective, but they want to monopolize the market. But we are having different standards at different stages. ARD is coming, and it will come in a smarter way.
I think we touched on the topic of standardization of interface and hardware now extensively. Let me see if there's any questions on other topics to this audience. The gentleman here was first, and you with the glasses, you will be next.
Yes, so this is Atharo from Cosmos, and justly my question was like, when we talk more about the S-Lego, when we talk about modularity, when we talk about reconfiguration, as already in-space assembly and manufacturing in low Earth orbit. So do we see this thing coming in around this 3 to 5 years into the game plan in future, or it will be a decade, like after that?
So is it a short-term or is it a longer-term topic? Who wants to take this?
So to answer that question, I'll start off with why. Why is there a need to do exactly that, right? So I'll just ask a quick question to everyone since it's hard to keep the audience engaged post the lunch. How many of you are from Delhi, in and around? All right. How many of you have maybe purchased any land near Gurgaon or Noida 10 years back? Very good. So the reason why I actually made that statement is because India has missed the bus, missed a good opportunity, and the answer is why. Because orbital slots are very expensive now, right? And also launching satellites is very expensive. Now, if you look at it, the number of orbital slots India has is less than 20. And again, I think Sir will come in and he's the expert over here on slots. But the point I'm trying to make is with limited number of slots, or if you have a limited real estate, you try to maximize the usage of it, right? So with a single orbital slot, how can I actually maximize my usage? How can I actually meet more number of customers, generate more business? So that is where SDR brings to the table. So with SDR capable satellites, one, you're reducing the amount of size. Two, you're actually giving more functionality and more future-proof. Where, for example, you have a requirement in 2 years from now and you actually launch a satellite, but 5 years down the lane, I mean, that requirement is off the table. You need to do something else. In software-defined radios, they can quickly send an update, change the frequency, change the frequency as well as change the from K-band to S-band to something else, Ka-band, and then ensure that the communication is established. So again, it's satellites these days, not just 10 years, even beyond that. You can even refuel your satellites. And having these software-defined capable satellites would make it much more cost efficient and also ensure that there's business sustainability in the long run. And I definitely think that we need to launch more and more satellites. If you look at the numbers, I mean, we have less than 25 LEO constellation satellites, where the world has more than 12,000. We have, I think, less than 20 geostationary satellites as of today, where I think the world has even more and very marginal. So compared to our population versus the number of satellites that we have, we need to ensure that we are picking up our pace and file more and do more to ensure that there's business continuity and sustainability.
Thanks. My question is related to this actually, which is that, and it's for Mr. Rakesh ji. India is still a very nascent commercial satellite manufacturing and system integrator. So since you've put together this TSAT-1A, I was just trying to understand how many components were sourced onshore domestically, how many components were sourced from outside the country, and where do you see the component manufacturing sector in India growing and enabling us to system integrate more and more satellites going forward?
Yeah, so as I previously touched, the ecosystem in India is still coming up in on a component basis. There is still a large gap in India to supply the components at the component level or at a package level. I wonder, in India still we have not seen the companies who come up with these modular solutions that I'm going to provide you an AOC system, I'm going to provide you the OBC, or these are the components of the satellite. I will say, as far as satellite is concerned, all the modular solutions. Today, I can't go to a website and see that I want to buy these 10 components for the satellite to put it together. I can't find the Indian supplier. So that's where the gap is. Coming back to the TSAT-1A, we have thousands of components, but in terms of package, there are around 12 or 15 odd packages, which we got it from outside, from technology provider. And our technology provider was actually able to provide it in very short time of 3 to 4 months because they were already in the supply chain of,
This is
managing
Satellogic
the-
that was
Satellogic,
assisting.
Yeah. So we were able to do that faster. But if we have to do same thing in India, it's going to probably take us a long time because we will be going to build to print spec with the companies here. There is nothing called an umbrella, this thing. As gentleman told, we are, as our population and the resources we have for the space and the satellites we want to produce, it's not matching right now. So of course, there is a large demand for component manufacturers. And the number of satellites we will be making in future may not satisfy the component manufacturers' economics. So they have to find out an international market also. So that's where, as a component manufacturer, you have to find a solution that how do you open market for the world to make your business sustainable, and how do you support us for when we want to make 10 satellites, but your business may demand 100 satellites supply. So that's the economics that everybody has to work on.
It's very interesting also from a non-Indian perspective. So there's a number of satellites components that you need to import right now. But if you look 5-10 years forward, how can you be autonomous, or for how many will you still be dependent from abroad?
Yes, so let me answer it in two ways. One is, what is in our plan, which will actually control the demand and supply of the components. The plan is very dynamic. So we have a plan to spread our businesses in different verticals. We don't want to be in one vertical only. So it's in EO, it's in communication, it is in other domains like ISR, defense community, and the different smarter markets which are opening up. So we will be, of course, going to different domains. And the supply chain for those making those satellites will be a little different. Maybe something common, something may be different because of satellites are, payload side, it will be different. Satellite point of view, it may be same. But right now, answering this question that how many satellites will be producing in next 5 years, 10 years, and what are the components, it's a difficult question right now to answer, to be frank with you. But of course, we say that we will be able to make a constellation of 10, 15 satellites in next 3 or 4 years. What type of satellites it will be, what will be, which segment it will be, a little difficult right now. That's why none of the companies from, I will not say Indian side, but the eastern side companies have a concrete plan of constellation of satellites. They have not come up from last 3-4 years. It's difficult because market is very dynamic here. Still, dependency on the outside partners will still be there because from the component level, like resistors, capacitors, everything is still coming from outside world. And there is also a geopolitical situation where we cannot get components from certain countries. So few countries are open, few countries are closed for us as far as because we have to be we governed by some law here in India, so we can't go to everywhere. So those component dependencies will still be there, but I don't know how far, maybe 5 years, 6 years, 10 years. But that will eventually reduce as we become vertically integrated in terms of the sourcing of components from Indian side. So this again brings me back to why do we need vertical integration? We don't need vertical integration. We are trying to make this economics work for, which demands us to do a vertical integration. If this ecosystem exists in India, we will be dependent on all the parties in India, not a vertical integration. We don't want to do everything on earth. We want to do something where we need hundreds of partners. This model will never end. We still need, after 10 years also, we will need hundreds of partners. But whether they will be here in India, they will be outside India. So this is a broad question. This will we'll keep on debating, but eventually we expect that 80-85% should be in India in next 5 years. That's my assessment, not the market assessment.
Well, thank you. I think we looked at the topic of vertical integration, standardization now from various different angles. Now, if you look forward, if you look into the future, what are some of the key technological and regulatory hurdles that still need to be overcome for a more widespread adoption of such smart satellite technologies? Do you have any views here in the audience? Or in the audience? Yeah? Any more questions from the audience? No? Oh, there's some questions over there, the other part of the building.
Hi, my name is Lalit. I'm from Hughes Network Systems. I think it's a great panel to hear all of you guys talking about the smart satellite. And today, we all know about software-defined satellite, SDS. We are pretty much talking about. Siddhartha, you mentioned about software-defined radios, changing the frequency spectrum. That's fine. When you're talking about the topic like unlocking the potential of smart satellite connectivity, the demand is increasing. The worldwide demand is going in terms of the gigabits, not even 100 gigabit, 100 Mbps, 200, multi-gigabit. So what do you think that the smart satellites, which you guys are talking about, how it's going to contribute towards the capacity handling, understanding of this demand, and how you're going to cater this particular side of the business, going with the smart satellite? You're talking about the small satellites, which have few capacity, you have the limitation of the slots, you are going to make it more smart and smarter. But seeing the demand, and which is increasing day per day, what do you think that the smart satellite, how it's going to help, and the way it's going to cater all those questions going forward?
So maybe I can answer in two parts. If I take into consideration where we are today, take into consideration SDR or RF technology. So right now we are targeting already, but we have already proven technology of 120, 200 gigabit with a small satellite with the beamforming, beam network, beam switching, all jingles and well. It's readily available. If you want to come to my booth, I can show you our SDR, which is ready doing with the active phase array antenna, 400 beams. You can do it. It's already there. So now the second part of the question, how do we tackle the future? The future, one thing I think it's my mistake also, we also did not touch base of free space optics or laser communication. That's also part of the next generation of satellites which is coming up. So we have been working for last 4.5 years with our partners in USA, Space Micro, to develop a complete end-to-end communication satellite and just free space optics for laser communication. So we have already designed 4 optics head on the top, back-end modem with fiber optic connection, and there are DSE, ADC conversions. We are doing 40 channels. Then each card is giving you about 200, 150, 200 gigabit capacity. From one satellite, we are targeting to have it 2028, 29, about 1 terabit throughput. There's one program which we are part of for Canadian Space Agency and NRC, National Research Council. So we have an optical communication consortium, OSC, and which Honeywell is launching first optical satellite in the next year, I think. So we are part of that laser communications equipment supplier. So that part we don't touch base here because that's another smartness of the satellite which is talking about. And that will resolve many issues what we are facing today, RF spectrum, this and that. Yeah. Because then we are no longer bound by the interference or coordination issue with my neighbor or anybody else. So that's the next generation of the discussion we can have.
So again, from a business perspective, you always need to look at ROI and who's your customer, right? So there's a demand, but what's the cost the customer is going to pay? That's very important to understand. And especially in the Indian market, I'll take for an example, let's say we actually bring text messages in flight, right? How many of us would be willing to pay, let's say, 500 rupees or 1,000 rupees for having that capability to text while we're on the flight, right? Not many of us. So again, it depends on where exactly is the need and how much are they willing to pay, which would then determine whether there's a need for the market and there's market potential or not. And why I'm saying that is SDRs, because you're actually optimizing to the fullest potential. Second, dynamically meeting the needs and requirements of the customer requirements based on a single, let's say 1 month, there's a customer need and you're actually addressing the requirement on emergency or somewhere else. So based on demand, you can actually rapidly adapt based on who the customer is. So I think that's where SDRs with high gain and multiple, I would say, beams, multiple channelization, frequency reuse can cut down the cost, make it much more cost efficient for the end customers. Like Chairman mentioned yesterday, us as a country, at least India, I'll talk about, where we have to first start out with multiple different applications increase the number of users who actually demand such satellite communications or real-time data services to be provided to them, so that they can actually in turn pay for launching satellites for companies like us, who can then launch and then provide these endpoint solutions to our customers. So I think it's a chicken and egg, but I think now, as Chairman mentioned, start with applications first because you're already late, and then slowly, based on now we have customers, now let's launch more, partner with them, and then launch more and more satellites to meet their requirements, which is much more safer business model. And I think Hughes is already doing that.
Yeah, I think Siddhartha touched upon my point. Why do we need to be smarter in this? Finally, it boils down to the customer who is paying for the services, like in communications, and how much cheaper we can make it for them. Forget about what we are putting in space. We have to be smarter to bring the cost down. Now, when we talked about classical communications, 4.5 ton satellite, you know how much it takes it to put it to the GTO and then to the GEO? It goes in hundreds of millions of dollars. Now, when you talk about the same functionality or better functionality satellite of say maybe 1500, 2000 or 2500 megabits per second capacity, in 200, 300 kg class satellite, you see from 4.5 ton to 300 kg or 200 kg class, how much the cost gets reduced. Now we are talking about ride share to the GTO mission. So that $50-60 million gets divided into 5 or 6 satellites. So you can imagine the cost of this has come down every 2 to 3 years. I will say the communication per bandwidth channel will come down by half. This is my economics, how it works. You know, next, whatever the cost today, after a couple of years, you'll see the cost will come down by at least maybe factor of 2/3 or half for the communication band. So this is the smarter way. But at the same time, when you go to the pockets to, if you have a GEO mission or if you have a LEO mission, we are not talking about, you know, which pockets are giving us this cost back for that bandwidth. So we have to be smarter enough to route our bandwidths, more channels towards the areas where it's getting us money back for that mission and constellation. We can't be just unsmart in a way that we just have bandwidth over whole of the India and we get back money from few metro cities. So that's what is the smarter way of operations, smarter way of weight management, smarter way of technology. So everything boils down to the cost. Finally, so that's where the big constellations like Starlink, they struggle for this because on the polar regions nobody is going to give you the same cost. Or even as that said, are you willing to pay for the text message of maybe $10 for next couple of hours of flight? So this is how the economics work. So we have to be smarter to bring the cost down. That's the only way.
So this is where I had started. If you remember, my discussion started from the cost point of view. Yes. Anything starts from the cost from the customer and then boils down to back.
Wow.
So
I think
we came that to the same point. We then made a real first point.
we're running out of time here now. So thank you very much for the many engaged questions. But before we wrap it up, I'd like to ask you to give a round of applause to our panel here, Michael, Rupesh, Rakesh, Gurvinder, and Siddhartha. Thank you.
Thank you so much, Mr. Rainer, and all our esteemed panelists for such a thought-provoking discussion. As we bring our insightful panel discussion on next-gen connectivity to a close, it's time to extend our appreciation to the esteemed panelists, to acknowledge their dedication and insights. Let us now proceed with the felicitation ceremony. I request Mr. Rainer, please come forward and help us with the felicitation. I request Mr. Gurvinder Chohan to please come forward to receive the felicitation award. I request Mr. Rakesh Bhan to please come forward. Mr. Siddhartha Sagar. Mr. Rupesh ji. And Mr. Michael Dowries. I now would like to thank you so much, gentlemen. I request you all to please come forward for a group photograph.